Hello guys, and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to look at how we can use static IP routing to train our Cisco devices on how to reach those different networks across our enterprise. The learning objectives are as follows: to understand what a static route is and to understand why we need static routes in the first place. So let's look at why we need them, how they work, and then we'll walk through an example to see what's going on behind the scenes. By default, Cisco routers only know about their directly connected networks and nothing else. If there is a network out there that is one hop away or more than one hop away, your Cisco router will know nothing, absolutely nothing about that network, and it won't be able to reach that network or communicate with it. However, we can solve this issue because we have the power to train our routers on how to reach those networks by using static IP routes. So to really see what's going on, let's walk through an example. So in this case, we have a headquarters site over here, and we have branch site 1 and branch site 2. Let's focus on the communication between headquarters site and branch site 1. So in this case, we have Rick, and all Rick wants to do, he wants to send an email to Morty. He wants to tell Morty that, hey Morty, I've been watching this really cool CCNA series by ABY Design and Tech, and you can visit this series and have a look at it by following this link. So he puts that link in an email and wants to send that email over to Morty. And you may be thinking, well, that's going to be pretty simple. The email just flows from Rick all the way to R1. From R1, it flows all the way to R2. And from R2, it flows all the way to Morty. Now, that does look simple. However, the traffic doesn't even get past R1. And you're thinking, well, wait a minute, why doesn't it get past R1? It's a pretty simple route. And this is the reason why. Because by default, Cisco routers only know about their directly connected networks. So in this case, R1 knows about this network over here. He also knows about this network over here, and he knows about this network over here. The reason being, because he has an interface which connects to each of those networks. In this case, FA01, FA02, FA03. He does not have an interface which connects to 172.16.2.0/25, which is the network that Morty resides in. So in this case, the email, which flows all the way to R1. The destination IP address of that email is 172.16.2.50. R1 looks in his routing table and like, well, wait a minute, buddy. I don't have a route to this network. I don't know how to reach this guy. I don't know who to send this to next. So I'm just going to drop this packet because I don't know who to speak to in order to get this traffic to where it needs to get to. He takes that packet, throws it in the bin, and it's gone. However, as network engineers, we can solve this issue. And this is how. We go into the command line of R1 and we simply just use this command. We use the IP route command. IP route. We type in 172.16.2.0 followed up by the /25 subnet mask in decimal, so in this case 255.255.255. Dot, squeeze that in, 12A. And then we have two choices. We can either define the outgoing interface or the next hop. So we can say, to reach this network, send the traffic out this interface, or we can say to reach this network, send the traffic to this next hop IP address. So this is the router, the next router in line to finally get to that destination. Or this is the outgoing interface, then the next interface I have to send this packet out of to get this packet to its final destination. In this case, let's go with next hop IP address. So I'm going to put 192.168.1.2. And just by using that command, that one command, we have trained R1 on how to reach Morty. So in this case, when R1 receives this email, he looks at the destination IP address, and that destination says 172.16.2.50. He's like, well, wait a minute, I know how to reach that network because I've been trained, I've been programmed by the network engineer that for any packets that have to go to the 172.16.2.0/25 network, I have to send those packets all the way to 192.168.102, my neighboring router R2, because he will know how to get there. So in this case, the traffic flows all the way to R2, and then R2 can deliver that email all the way to Morty. However, we still have an issue because we haven't trained R2 on how to reach 172.16.1.0/24. So now we have to go and do the same thing on R2. We have to issue the command IP route 172.16.1.0 255.255.255.0 192.168.1.1, which says to reach this subnet, this network over here, send the traffic all the way to R1. And there we have it. We have end-to-end reachability between Rick and Morty. So we're static routing. All we're doing, we're going on the router and we're telling the router where to go to next in order to reach any network which it doesn't already connect to. So in this case, I would have to train R2 on how to reach this network over here, this network over here, and this network over here, because he doesn't connect to those networks. And in this case, all three routes will just say go through R1. And the same thing over here. For R3, I have to train him on how to reach this network, and this network, because he doesn't have a direct connection into any of those networks. And in this case, like with R2, the next hop is just going to be R1, saying that to reach these networks, communicate with R1. Now, when I configure these static routes, the next hop IP address has to be an IP address which resides in a directly connected subnet. So in this case, even though R3 connects to R1, I can't tell R1 to reach this network over here to send it to 192.168.1.1. Even though that's R1, R3 doesn't know about that subnet. He doesn't know about that network because it's not an IP address in one of its directly connected networks. So we have to define, when we define the next hop, it has to be a IP address the router can already reach without having to have a static route put in place. So we have looked at why we need static routes, how they work. In the next video, we're going to look at how to configure static routes on a Cisco device. If you have enjoyed this video and would like to see more content like this, then please subscribe to my channel, and thank you very much for watching.